Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on the Space Nuts podcast, episode 143. And no dilly-dally, no waiting around, no silly comments, no reading the Encyclopedia Britannica from front to back, every volume. Without further ado, I introduce Professor Fred Watson. Hello, Fred.
Hello.
How are you?
I'm trying to make up for the verbosity that we've just heard.
Yes.
By being clipped and short.
Hello. What was it I heard Chevy Chase say in a movie once? I apologise for my bellicosity.
That's actually a good line.
Yeah, it is a good one. I like it.
It makes it sound as though you've got indigestion.
Yes. Now, we've got a lot to talk about tonight. SpaceX, with its successful docking of the International Space Station, that looks like a giant leap forward for mankind. We're also talking about the moon getting sunburn. That's weird. And we've got a couple of questions we're going to knock over tonight. Someone's asked about the GPS effect of a magnetic switch, or the effect on GPS systems of a magnetic switch. That's the reversing of the polarity of the planet or something. And a question about the Higgs boson, which we haven't spoken about for a little while, so it'd be interesting to get back onto that. But Fred, firstly, I have to make a correction and
Yes, you do.
something of an apology. I thought I got away with it. I thought this one will go through to the keeper, to use the Australian cricket analogy, or the catcher as you would in baseball. But no, somebody picked me up on it listening to another podcast, which we share material between our podcast and others. And someone's picked up on it and written an email to our all-consuming father. And he's written to me and said, "Do you know anything about this?" Yes, I do. I did unfortunately refer to a member of the crew of Virgin Galactic's test flight as a male cameraman, and his name was Beth Moses. So my apologies to Beth. Beth is, in fact, a female, and she is the first passenger on the Virgin Galactic test flight and the chief astronautic instructor for Virgin Galactic. So my apologies to Beth. In my defence, I got a glimpse of her rising above the back seat, and it just sort of manifested itself in my mind as a bloke who probably was taking the footage from behind with a camera. But it wasn't the case.
Despite the fact that your offsider said, "I think it's a woman, Andrew."
Well, you could have been a little bit more direct.
Well, I was pretty sure, but I only caught a glimpse as well. But yes, it was Beth, and well done, Beth. As you said,
Magnificent.
The first passenger on one of Virgin Galactic space planes. It's a really big milestone, which I think it bodes well for the future of the mission.
Indeed, it does, and I'm sure she had an absolutely wonderful time. She had a massive smile on her face, and I would too if I was up there for free. But
Yeah. Look, you might. I don't know whether you've watched this, but I did afterwards. There's a really nice interview with her on the web. You find it very easily with Virgin Galactic's website.
Excellent. All right. Which dovetails beautifully into this story, because their nearest competitor, or one of their nearest competitors, SpaceX, has this week come up with a success story, Fred.
Indeed, that's right. And like Virgin Galactic, SpaceX is is the brainchild of a very wealthy billionaire with the good of humankind in mind, I think. SpaceX, of course, Elon Musk's company, which very early on in what you might call the new era of spaceflight, which really dates from 2010 when the announcement was made that NASA was going to concentrate more on the kind of blue sky stuff and leave the taxi work to private enterprise. In 2010, SpaceX was one of the early pioneers of that. And I think it was in 2012, Andrew, that the Dragon capsule, which is the SpaceX orbital module, the first one docked with the International Space Station. It was used to take supplies up. So it's taken another 7 years to get that capsule from being capable of only taking cargo to being certified for human use, because that's what we're seeing now. So last Saturday, the Dragon capsule was launched from the SpaceX launch pad and docked about 30 hours later, I think, if I remember rightly, with the International Space Station, carrying on board not humans, but a kind of mannequin that was used, that was festooned with sensors, so that people would know what kind of accelerations and all the rest of it was being dealt with.
And it had a name.
It did have a name.
It was Beth. It was Beth Moses. No.
It did have a name, and I can't remember what it was.
I have no idea.
No, it did. They gave it a name, as you do with things like that, and that's terrible, isn't it? My journalistic capabilities are leaving me behind. Maybe by the end of this conversation, I'll have rediscovered what that name was. But yes, so this mannequin was sitting in the capsule, as I said, loaded with sensors, so that everybody knew what kind of conditions it experienced. I've got a feeling it was a female name they gave it.
Beth Moses certainly fits.
That's the wrong name.
Ellen Ripley. Was it Ellen Ripley?
Might have been Joanna Lumley. Who knows?
I don't know.
I'll get there soon. Don't you worry.
It was Ripley. It was Ripley after the Alien movies.
That's it. It was Ripley.
Yeah, there you go.
Yeah, well done. Your brain is obviously more switched on than mine at the moment.
Have I redeemed myself is the question.
Oh, not a chance. Forget it. Okay. With only Ripley on board, they
believe it or not,
the Dragon capsule docked automatically with the International Space Station, because before with these cargo capsules, the ISS crew had to grab it with there's a robotic arm on the...
Oh, yes, there is.
Yeah, it's made by the Canadians. It's one of their big contributions to the ISS. And they had to use that to sort of haul it in. But this time, with the new improved human crew type capsule, it docked automatically and apparently was absolutely flawless. And I believe that the current crew of the International Space Station have all gone inside the capsule to have a look and see what it's like, because they will no doubt in the future be traveling up and down to the space station in capsules just like that.
Well, let's face it, who's going to stop them?
Well, exactly.
Don't go in there. Oh, come and stop me.
Quite true. That's not quite true, because Boeing also are contracted to NASA to provide taxi services to the International Space Station. I believe their spacecraft is called Starliner. I can't remember, but I think it's Starliner. So that is also scheduled for trials later this year. But what I was about to say was that the test for the Dragon capsule is not yet complete, because, of course, they've got to get it back in one piece.
And by the time people hear this, they'll just about be ready to start that journey.
That's correct, yeah. I think it's Friday this week when the return journey will be made. Hopefully all will go according to plan. Elon Musk himself has expressed concerns about the heat shield. I think show-stopping concerns, but
yeah, I was about to say that's a really great way of getting media attention when you want to show something off.
I think the heat shield's going to fail. That will be a good way of getting the cameras on it.
Yes, indeed.
But we'll see. We will see. The answer will be known by the weekend. My guess is that it will perform as flawlessly as it has done so far. I think it's a marvellous example of the way this vision of commercial, routine commercial flights to and from the International Space Station is taking shape.
Civilian astronautics.
Exactly so.
Is that what we call it?
Well, you can call it what you like, but it's basically the commercial sector taking doing the legwork, basically.
Yeah, when NASA initially decided to go down this road, and I think you and I talked about it, I was a little bit surprised and thought, oh, gosh, that's really going to set things back. But I think it's had the opposite effect.
Yes, that's right. It has indeed. It's certainly, spurred companies like SpaceX to really go the extra mile in terms of designing these craft. I don't know if you've seen pictures of the Dragon human crew capsule.
Yeah, I have.
Very elegant indeed. Looks very much like the spaceships that I used to read about when I read Dan Dare back in the 1950s.
Wow.
Stuff.
Yeah. And while we're talking about reading science fiction novels, thanks to the 3 people who've read mine, I'm really appreciative of that.
Good. I haven't got to it yet, but I will. Don't worry. As I keep promising, I shall read it.
Oh, that would be wonderful. So all full steam ahead for Elon Musk. So he's in the news again and continues to dominate the news in this arena. But he's certainly got some competition, Fred.
That's right. I think we'll see, throughout the remainder of this year, I think we'll see many milestones of this kind, both from the likes of Elon with SpaceX and Boeing, as I mentioned, with the Starliner, but also, of course, with Virgin Galactic. I think what we saw with Beth Moses in the background there was just the start of exciting things this year.
So it wasn't Ben Moses, it was Beth. I'll have to remember that. Okay, you're listening to Space Nuts. Andrew Dunkley here with Fred Watson.
Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, we're going to talk about sunburn, something that a lot of people in Australia suffer from, especially the Caucasians amongst us, because let's face it, we're not built for this environment, and we have one of the highest rates of skin cancer of anywhere in the world. And at my age, I'm starting to show signs of it, because when I was a kid, you just didn't wear sunscreen. That wasn't cool. Now it is. And we suffer vitamin D deficiency instead. Something the sun has provided for us. But what we're talking about now, which is a really elongated way, again, of getting into the story, is that the moon is sunburnt.
Yeah. Well, that's the story, really. So why is the moon sunburnt? Because the sun actually deposits not just ultraviolet radiation on the moon, which is, of course, what causes sunburn on Caucasian skins. It also deposits subatomic particles because you remember the solar wind is rich in electrons and protons, and they are constantly streaming towards the environment, the solar system environment, which is occupied by the likes of the Earth and the Moon. Now, the Earth, of course, is protected from direct blasts of radiation by its own magnetic field, and that's what sort of steers the subatomic particles largely away from the surface. They funnel down into the poles of the Earth, the magnetic poles, which is why we see aurorae near the poles. But on the Moon, there is no magnetic field to speak of. Certainly not a global magnetic field like the Earth has. And so these subatomic particles simply hit the deck. They land on the surface of the Moon, and over time, they change its texture. In fact, they discolor it. They turn it a rather darker shade of browny grey, which is the natural colour of the Moon. So we've known that for many years, but what we've only recently understood, and it's thanks to a spacecraft by the name of Artemis, which is the acronym is appalling, really.
Shocker.
Reconnection, turbulence, and electrodynamics of the Moon's interaction with the Sun.
Okay.
It's, somebody really deserves an award for that acronym, I think, because it sounds great when you say the word, but when you spell out the meaning, it gets a bit laboured. Anyway, excuse me.
And that's never happened before in astronomy or space exploration.
No, that's right. Well, I've been responsible for one or two voted acronyms myself, which I won't go into here. But Artemis has been placed, in orbit around the Moon quite some time ago. It was originally part of a mission that involved a constellation of 5 satellites in orbit around the Earth, looking for energy releases that come actually from the Earth's magnetic field, its magnetosphere, things called substorms, which are basically the phenomena that actually go to enriching the aurora. So that was the original mission of what was then called Themis or Themis, begun in February 2007. But then 2 of the 5 spacecraft were redirected into orbit around the Moon, and one of them is Artemis. And why am I telling you all this? It's because they're equipped with very sensitive magnetometers, devices that can remotely locate magnetic fields. And in fact, that's where the story gets really interesting, because as we just said, the sun's effect on the Moon has been to discolor it. It's changed its surface because of this bombardment with radiation. But a few places where there are kind of swirls of lighter stuff, really weird looking swirls, and they tend to be around mountains. And what Artemis has done is measured the magnetic field around those swirls, and it turns out that these mountains are magnetic. So if you've got a mountain with more of a magnetic field than the Moon itself, than the Moon's background, what it's going to do is tend to basically swivel the direction of these subatomic particles and maybe sweep them away, so that what you get around the mountain is a clear zone. It's just like when you put the slap of suntan lotion on your arm, and that's the bit that stays white. It's rather like that. So the magnetic field effect of these mountains has been to steer away the subatomic particles, so they're not deposited on the Moon's surface, and it leaves the Moon a lighter color. And it gives that area a very sort of otherly, if I can put it this way, otherworldly look.
Yes.
There are sort of swirls of brightness rather than, the sorts of different colouring effects that you expect to see on the moon.
And you can only see that through infrared?
It would be enhanced with infrared. That's right. Yeah. So it's very much the case that you use whatever means you've got at your disposal to see whatever results you're looking for, and infrared enhancement is certainly one. So I think that's a really quite remarkable result, and it's certainly one that I wasn't expecting to read. It never occurred to me that there might be regions of the moon's surface where local magnetic fields would actually sweep away the direction of the subatomic particles and give you this clarity.
I suppose we shouldn't be surprised, because we always seem to find unusual anomalies existing in various parts of the solar system and the universe that previously were unthought of. Like variables in the gravity on Earth. I mean, they're very minor, but they exist. It's not the same everywhere.
Yes, that's right. You're quite right, and clearly you're much more forward thinking in these matters than I am.
That's because I write science fiction.
Yeah, but I think you're right, and I guess it comes back to something that I remember being fixated on decades ago. When we look at galaxies and things like that, we see beautiful images of galaxies, but we're seeing them from often hundreds of millions and sometimes many billions of light years away. And what you don't see is the structure, the detailed structure of these things. And it's the same with any celestial object. When you get a distant view of it, you only see the global properties of whatever it is. And it's only when you really start looking closely, and for example, by putting spacecraft in orbit around the moon, that you see these anomalies and these details that really add to our understanding of the world of space and the objects that are in it.
Mm. And very, very soon, SpaceX will be taking up a massive cargo of sunscreen, and they're just going to pour it all over the moon. I think they'll need like 3 gazillion plus.
I think yes.
Anyway, that will probably mess up the Chinese plans, but we'll see how it goes. But yeah, the moon is sunburnt except for a few spots where there's magnetic activity. Interesting.
The problem with science fiction writers is their ideas carry them forward in a way that sometimes is not necessarily constructive, like sunscreen for the moon.
I'm thinking of an entire novel, probably in 5 parts.
Yeah, 5 parts, yes. One for each of the spacecraft in the old Themis setup.
Yeah, maybe. Definitely not. You're listening to Space Nuts, Andrew Dunkley and Fred Watson, of course.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, Fred, we're going to try and tackle a couple of questions this week. The first one comes from Tony Cullymore. Hi, Tony. Thanks for your question. And he says, hi, Professor Fred. You're never going to get away from that. And Andrew Dunkley Esquire. You got that right too. I've been wondering what happens to the world's GPS systems when or if the magnetic poles switch places. I know the poles wander about a bit at present and things seem to work okay, but a switch of hemispheres, will that be a problem, or are the GPS satellites programmed to handle it? Tony, long-time podcast listener from Tasmania. Thank you, Tony. Over to you, Fred. Because we've been talking about this a lot. I interrupted. We've been talking about this quite a bit. The movement of the north magnetic pole, for example, and what sort of effect that is having on GPS. But yeah, the changing in the magnetic field, that's a totally different ball game.
That's right. It is. So what I guess what this gets sort of mixed up with, and maybe we mixed it up ourselves when we're talking about the discussion you've just mentioned.
Well, no, you did, because I never get it wrong. I mean, I never mix up male and female people, for example.
Never. Beth and Ben and all the rest of it. Yeah. Anyway, just neglecting that for a minute.
Please.
We certainly did talk about mobile phones and their accuracy when the pole is shifting, because it's shifting at the moment, as we've mentioned, I think at 50 kilometers per year. It's really herring across the northern part of the Arctic. But GPS itself is quite independent of that, because GPS, it's an extraordinary clever system that relies on, first of all, a large number of satellites. As you probably know, if you've got a GPS system that tells you how many satellites it's picking up, and mine doesn't do that anymore, they seem to disregard that kind of thing. But the early ones certainly said, you're only getting 3 satellites, you haven't got enough to get a good position.
Oh, yeah. I used to have a golf GPS system that told me how many satellites that I was honed in on.
Yeah. Yes, that's right.
And often it was like 15 or something.
Oh, well, that's what you need. So what you're doing with these satellites is they all have high precision clocks on board, which are beaming out signals. And it's all about the timing of your little decoder, the GPS decoder in your phone or whatever it is. It picks up the coded signals, the time signals from these spacecraft. And because what that lets it do is work out the distance to each one of them because of the time delay in the signal coming down to Earth. I mean, these are low Earth orbit satellites, so the time difference is a fraction of a second, or the time lag. But the GPS units have clocks within them that are accurate to be able to time these to billionths of a second, basically. So each satellite beams down a signal. You've got half a dozen of them, perhaps, that your decoder in the phone or the GPS unit says, well, that one's taking this long to get to me, that one's taking this long to get to me. And by looking at them all simultaneously, it can tell exactly where you are, because there's only one solution to the problem of where on the Earth are all these signals going to have the time delay that you've recorded. So that's kind of how GPS works. And because it's dependent on, first of all, orbits, and secondly, time devices within the spacecraft and within your phone, it is independent of the magnetic field. So it won't affect GPS. And I guess that's one of the reasons why GPS is so powerful, and of course why it was very important and really set up for defense purposes originally. It's not something that's perturbed by the Earth's magnetism. What is, though, is if you've got a phone that's got a compass in it, the phone's knowledge of north, which really should line up with the GPS knowledge of north, that's the thing that needs the magnetic map that we were talking about last time when we mentioned this to get it right. So the GPS itself is okay.
Okay, so that's not going to be a problem in the event of a reversal of the magnetic field.
Right.
All right. There you go, Tony. Asked and answered. And thank you for your question. We'll move on to a question from Damon Matthews. He says, hi, guys. Love the podcast. I think Andrew does an amazing job. Hang on, let me reread that. I think you guys do an amazing job and bring joy to my job when I'm listening to you too. My question is this. If Higgs boson is the particle that gives all matter its mass, and the larger the mass, the stronger the gravity, would we be able to understand gravity once we fully understand the Higgs boson? Interesting question. It's
a great question, and goes really to the heart of our ignorance in terms of what gravity is all about. The studies that led to the prediction of the Higgs boson, you and I have spoken about this before, but they go back to the mid-1960s at the University of Edinburgh, which is where I got my PhD from many years ago. That's what allows me to take off the Scottish accent with impunity. So Edinburgh was the home, and still is, of Peter Higgs, who was the theoretical physicist who said, our understanding of the subatomic world is incomplete. There is something else that gives particles their mass. Now, it's not quite as simple as that, because particles can also be regarded as what are called fields. In other words, you could envisage a sort of background force in the universe, which might be called the Higgs force. And we, in the world of physics, we tend to regard particles and forces in that sense, at least as far as bosons are concerned, we regard them as interchangeable. So the Higgs field is what was really predicted. And in a sense, the Higgs field is manifested by the Higgs boson. It's almost like the wave, the wave motion of light being manifested by the photon, which is a particle of light. It's this particle wave duality coming up once again. They are the same. They're two things simultaneously, and the Higgs field and the Higgs boson are the same. And so the way to think of the Higgs field, and this was something that was put to me when I was really starting to learn about the Higgs boson back in 2011, I think it was. The Higgs field is, you can think of it as like a jar of honey, okay? And you stick a teaspoon in the jar of honey. If the honey's not there, the teaspoon moves around very freely. Mm-hmm. The honey's there, it feels the resistance. And that viscosity of the honey is kind of analogous to the Higgs field, which is why people say it gives these particles their mass. Because what it means is if you've got this field that's a bit viscous like honey, and you're trying to move subatomic particles through it, their resistance is what we see as the mass of the particles. I don't know whether that simplifies it too much or doesn't simplify it enough. But what I'm saying is that it's a property of the Higgs boson itself that is the thing that gives the particles their mass or the appearance of having mass. So now, Damon's next step in the argument is absolutely right. It's mass that gives objects the property of gravity, not galaxy. Galaxies are a bit bigger.
Yes.
Mass gives an object the property of gravity, and gravity is something we really don't understand. So would understanding the Higgs boson better open our eyes to more understanding of gravity? And I think the answer is yes. If you can find out all you can about the Higgs boson, then you are bound to, unlock some hidden facets of gravity that we didn't see. But maybe what's more likely to happen, Andrew, because this is the way particle physics seems to work, you study something to death and you find something that really does not make sense. And there are things in what's called a standard model of particle physics which are already like that. And that's why people suspect there are other subatomic particles that we haven't yet discovered, and they might contribute to dark matter and things of that sort. So it's finding the inconsistencies that really open up the new knowledge. And maybe as we study the Higgs boson further, and I have to say this might be already happening. I'm not at the moment not as well across the subatomic particle world as I might be. If people are studying the Higgs boson and finding inconsistencies in it, that might open the way to new physics, which might in turn open the way to our understanding of gravity.
And well, that answers my question. I was going to say, are we in a position to crack the Higgs boson code? And the answer is maybe, because they might be working on it.
I think they probably are. Yeah, I think that there are probably a dozen PhDs being written as we speak on the Higgs boson, none of which I know about.
And my guess, and it's just sort of a throwing it out there and hoping for the best type of guess, but my guess is that they're going to have one of those eureka moments sometime in the future, and who knows when that is, and we will suddenly make a giant leap in terms of understanding the Higgs boson and perhaps gravity, and maybe that'll open the door to so many other things that we still can't answer.
I think that's exactly the hope of all of physics. That eureka moment is what people are yearning for, especially when things don't seem to be heading that way. And just to digress for a minute, what has happened in the world of particle physics is that people have become very discouraged about what 2 or 3 years ago was the great white hope of particle physics, the idea that there might be this thing called supersymmetry, a kind of hidden regime of much heavier subatomic particles, one of which might be the subatomic particle that causes dark matter. Supersymmetry, it's a beautiful theory, it's very elegant, everybody in the theoretical physics world believes in it, but there has been no evidence whatsoever of an experimental nature. And so the Large Hadron Collider, for example, has been looking for supersymmetry now for about the last 5 years, and not a hint of it, which has been very disappointing. There's more to find out, clearly, but we seem to be drawing a bit of a blank at the moment.
Maybe we're asking the wrong questions.
Yeah, I bet we are.
I heard that in a movie once too. Movies are full of wisdom.
You know, it's a good line for a science fiction novel, that. Maybe we're asking the wrong questions.
You know, I started writing my next novel the other day. I just was sitting there thinking, what am I going to do? I'm going to start writing. I know that Parallax is only just out on the market, but I just, people who are saying, I want to read your next one. And I'm thinking, well, maybe I better start writing a next one. So it's not a sequel. It's a totally different book, but I've started.
It doesn't involve sunscreen and the moon, does it, by any chance?
No. I guess I can reveal a little bit, but it's about a time when this planet has forged past all its divisions and destruction and become a cooperative place, and everything is hunky-dory, and that's all I'll say. That's all I'll say.
Utopia spoiled.
After 7 world wars, I might add.
All right, that's depressing.
It is rather. But that's where we'll leave it. And thank you, Damon, for your question. Hope we gave you an adequate answer. Adequate is all we basically aim to achieve on Space Nuts.
Sometimes barely that.
And thank you, Fred. A pleasure as always.
Great to talk to you, Andrew. We'll ramble on again next week.
Indeed, we will. Professor Fred Watson, astronomer at large, who joins us every week on Space Nuts, and we are so pleased that you join us too. And we will look forward to your company next week. From me, Andrew Dunkley. Thank you for listening.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.